I don't
Yeah.
know.
Give me a second. Don't talk until it's online, and then I silence it, mute it on YouTube, and then we can start. Okay, welcome to the Essence of History. Amanda is not with us today. I think she's bored with numbers and anything math related. I'm Dr. Abbasi for Essence.
Misha?
I'm Jimmy.
So we have three nerds talking about the numbers.
Well,
Oh.
the history of it, but not really the application today, right?
Well, history and application are not separated. So meaning these are very, very interrelated things. Now, but when I tell number, Jimmy, what comes to your mind?
Numbers like
Go number, go, start counting numbers.
1, 2, 3, 4, 5. Just
Okay.
Yeah.
Keep going.
6, 7, 8, 9, 10, 11, 12.
Okay, but to start there. Once you get to 9, something changes.
It's the digits start over and add one more digit to it.
So we have everything we know these days about the numbers is based off what?
10.
What's the base of 10? But actually, you told me though 9 numbers, not 10 numbers. Why?
I forgot to tell you 0.
0. For a long time, for thousands of years, we actually had the numbers without 0. 0 didn't even exist for a very, very long time. The Indian scholars finally came to the concept that nothingness is a number.
Nothing is something.
Nothing is something, yeah. And
Sounds
that
pretty
actually,
evil.
that's deep.
That sounds evil.
No, that is very deep. People were scared of 0. As a matter of fact, when the concept of the 0 was introduced to Europe, the church went crazy that what? That you cannot have a number for nothing and so on. That's evil. That's so on and so forth. But what you notice is that when you go to 9, then you use the 0 and the first number again to move the next way. That's what the base of 10 is. But why base of 10? What I mean, as a matter of fact, I think a base of 10 is made up, right? Or is it any reason we should, is it something inherently important about base of 10?
My guess is just made up. If we have something representing 11, like writing like this, we might use it. That's my guess.
Yeah. What is the most used base today in humanity?
You mean in terms of number and counting?
Yeah.
Or just used by humans in general?
No, well, it's used by by proxy as general. What's the number base?
10,
10,
2.
10 or 2, yes.
Yeah.
I'll say 10.
Well, which one, 10 or 2?
I stand 10.
Well, I'll go with 10. Normally people use 10, but if you do computer stuff, you use 2.
Yeah.
Okay, well, for every time you count, computer counts 1 trillion times.
Yeah.
So base of 2 is the most used base of numbering as of now. Even though we don't calculate with that, but everything we use first get translated to the base of 2, and then it get used, right? Or do you think computers, there's another base that computer use or used to use, maybe not that much anymore, but still use that. What's that?
I know 16.
16.
Sometimes they use.
16, hexadecimal. So how does the 16 works?
If I remember right, after 9, it go to character like
Yes,
D, F,
A
E.
10. No, it starts with A being 10,
Okay.
B being 11, and so on until F. F is 16, F is 15 actually. And then when you get to 16 on the base of hexadecimal base, then you go to 1 and 0. So 1 and 0, which is 10, in the base of 10 is actually 16 in the hexadecimal, right? So,
I'm lost.
Wait,
Lost. Why do we use
10
16?
is 16 in 16 base?
yeah, why do we use it? Why do we use it?
I mean, I get binary and I get count to 10, but why 16 though?
I don't know, because all I know is in my childhood, some games are counting numbers using the 16 way.
Anything to do with power of 2?
I guess
Okay,
so.
well, let's start with Chinese old counting. You guys know abacus, right?
Yep.
Abacus is?
In a very vague way. I know what that is, but at one point I learned how to use it, but it was just very mentally demanding. I think it has a
Well, no,
memory system.
actually, it's a wonderful, unbelievably wonderful thing. It's not demanding. It's demanding if you don't know it. Otherwise, abacus is a fantastic machine for calculation. And I'm going to share a picture of it.
I know people
that-
calculate very fast using it.
Oh, sure. Faster than you can type on your calculator. It is on the right up is a picture of abacus. You see that there?
Yep.
So, what is the base of the abacus? What's the abacus based on?
I forgot how to use it.
Base of it's actually abacus is the base of 5. You
Okay.
move the beats to one side. Once you get to the 5, you bring one of them down, and then you can start over again. And so it's a practically base of 5. And then later on, they made it base of 10 because 10 was more. But the ancient Chinese was base of 5 because you have 5 fingers. Now,
I mean, you have 10 fingers, both hands.
but maybe you want to use only 5 of them to count.
So, what are the rationales of having something like an abacus?
Well, the rationale is to calculate. Now, why do you need to know the numbers at all? I mean, literally, in your life, it's 5,000 years ago, the Chinese, or 5 to 7,000 years ago, the Chinese are creating agriculture and so on. Why does a Chinese man need to be able to count?
Why does what? Why does Chinese need to count? Everyone needs to count.
They want to sell stuff. They
Yeah,
want to
yeah.
count.
Like keep track of.
I have
No.
sheep, you have ducks.
Yes.
And you give me 5 ducks, I give you a sheep. But how many ducks and sheep are we going to exchange, right? So here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. So 2 5s and 2 ducks. I get for that, I want 3 sheep. No, I don't give you 3 sheep. I give you 2 sheep. 1, 2. So you see, it is very practical thing. Numbers are necessary for very practical reason. Okay? So you understand, in this kind of practical sense, 0 had no meaning. 0 had no use. So what? I give you 0 sheep, you give me 0 dogs. That doesn't happen.
Yep. In
Okay?
terms of counting to 5.
Yeah. But now, what if I told you Chinese based on 5 wasn't even the only thing? That in Mesopotamia, where we took over all of our counting, there was a different base of counting. Something that is considered very, very complex now. What do you know about the base of counting in Mesopotamia like 6,000 years ago?
Is it base of 60?
Yes, it is base of 60. And that is why an hour is 60 minutes. And a minute is 60 seconds. So how do I count to 60?
I don't know.
The number of the knuckles, bones in my hand. Knuckles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7, 8, 9. So 1, so it's 12. 1, 2, 3. So 3 in each of the finger
Well,
takes 12. Okay. And once I'm through with them, 1 comes up. So 12, 24, 36, 48, 60. Does that make sense?
Yep.
Why is it important? Why was it for Mesopotamian important to have a base of 60?
I don't know.
I think it's just different culture have their different base of standard. Like Chinese,
No, it's not just
fine.
standard, it's about practicality. It's about the practicality. See, we talked about it's a very practical thing. They don't do math with it, they don't do algebra with it, they don't do analysis with it. It is a very practical thing. I give you 12 dogs for 3 sheep or 4 sheep. Okay? 12 dogs for 3 sheep or 4 sheep. Now, what about if I give you half of that? It's 6 dogs. What if I give you 1/4 of that or 1/3 of that? How many fractions are in your base? Okay, like you get $1, you divide $1 in 100, so you can 100 ways you can divide $1. What about if $1 was 3.7 cents? That doesn't work, right? So you need something that you can have full fractions.
So
So
60 is a good number that can have a lot
it's
of
a fantastic numbers for fractions because 10, how many fractions do you have for 10?
4.
Or
No, 5. Wait.
1,
1 doesn't count.
2,
1 doesn't count. 1 is the
2,
whole number.
5,
Five.
10. 4.
Huh?
3.
2
3?
and 5 and 10.
2, 5, 10.
Yeah.
Okay, the same number doesn't count. How many
Okay. 2
fractions?
and 5.
2 and 5.
2. For 10, you have 2 fractions. Okay? It's either 0, 10, or 2 fractions. For 12 already, how many fractions do you have for 12?
2, 3, 4, 6.
4.
2, 3, 4, 6, 4. Double the 10 already. How many fractions do you have for 60?
2, 3, 4, 5, 6, 10, 12, 15, 20,
Yeah, a lot more. 30 is a
30.
fraction
30.
of the 60. So you see that there? All of a sudden, if you are exchanging things, that becomes very, very practical things. And for thousands of years, actually, that was how we did how we like I come to you in a half an hour or 1/3 of an hour and so on and so forth. It was a very practical way of having the numbers actually help us in our daily life. And so we have had numbers long before we could write them. So spoken language, how old is the spoken language, Misha? What do you think? How long have we developed spoken language? Humans have developed spoken language.
Like, what is the spoken language? Do you count monkeys? Do you think monkeys have spoken language?
No, I think monkeys, they have a way of communicating, but with the spoken language, I mean the language that makes of words.
Mm,
I give you a hint. We have about 100 to based on our best knowledge, we have about 120,000 years of way of communicating. But how long do you think we have language that's made of words?
So 100,000 years of
About
communicating.
120,000 years, whatever is our ancestor.
45,000.
Actually, very good guess. It's about 40 to 60,000 years that we have refined our language to the words and so on. Now, when did we start writing?
I guess 20,000 or
No,
10,000.
not even. Yeah,
200,000.
no. You mean
No?
we could write before
Longer?
we could?
Yeah,
Do you
I
think
would
we could
assume
write
so.
before- No, you think we could write before we could talk?
Yeah, why not? Like, I like writing.
Right? Yeah. Okay. If
Why
you
should
want
I
to go that way.
communicate? I like
If
to
you
write on a
understand,
cave.
why not? Why can we not write before we can talk? What
Because
are we
you
going
don't
to
know
write?
Well, I was kind of like mixing the concept of writing and painting, like painting a
Yeah,
mural on a
painting.
cave.
No, I'm talking about writing, not painting. Yes, we
Oh.
could paint for a long time. So about 6,000 years. That is the longest that we could actually write. And
Much
Even
shorter than I
Carve
expected.
on a piece of stone or a turtle shell.
well, no, you see that there, painting and writing are two different. I think if you know that old Chinese language was a pictorial language, as hieroglyphs were.
Yep.
But that is when we went from drawing a man stabbing a bison in the prairie to actually making a symbol for a man, making a symbol for a kill, making a symbol for a bison. Writing and that was a fluid, you're right. That was a fluid motion from drawing a picture to making a picture to a letter or to a language, to a written language. That happened about 6,000 years ago. As a matter of fact, the first language developed both independently in China and Egypt, they were pictorial. Hieroglyphs is what it is. Okay, but then we did something more. We took the sound of that picture and combined it. We used the sound to represent spoken language. That like the sound of the snake became like a say. Okay, but we draw a snake, and that is why S in English look like a snake because it came from hieroglyphs, which was an actual snake. Does that make sense? So
Yeah.
it went from the picture of the snake to sound that represented S, and then it evolved to be S English S because we took lots of our letters actually from hieroglyphs. It went from Egypt hieroglyphs to Greek to Latin. Okay, so let's talk about the actual numbers. So eventually, about 6,000 years ago, we start developing a language, written language. We start writing. How did you write numbers?
Well, in Chinese, especially in Chinese, you like write strokes. At least that's
Oh,
true from one,
yes,
two,
yes.
three.
In
One
most
stroke,
of
two
in most
strokes.
of the languages, it's the same. You know, like if you have one, you have one stroke or one line. If you
Yeah.
have two, you have two line and three. And most of the other language, then when you get to a certain number, then they put a number across, and then with time that change to another symbol.
Yeah.
Okay, so they tell me about Chinese. How the Chinese numbers are made, 1 to 10. What does it look like? Try to describe it.
Well, the first three are very intuitive, like one strokes, two strokes, three strokes, and everything
four
from
is the-
4 to 9, like they're just the way they are.
Five is special. Five is exactly 5 stroke.
Oh,
It's
5
just
is
in
5
a
strokes in a different
organized
way.
Yeah. So
Are you surprised now that the abacus and the signs are, when you get to the 5, there is a different number? Does
Yeah.
that make sense?
yeah,
So,
yeah.
Yes.
In 5 it went to Z, right?
Oh yeah.
yeah, there
Abacus,
you
huh?
go.
Move
There
away.
it is.
Excel. What do you know about counting?
Yes.
Move away. Excel.
Is that correct, or am I? This is not
Yeah,
correct.
this
Yeah,
is
they're
correct.
correct. But are they
Correct.
simplified? They're
These are
just
simplified.
Simplified. So, but either way, so you start writing the symbols now. Originally, in most of these languages, the symbols didn't stop at 10 because 10 was not the base.
Hmm.
Okay.
Can you show us what Mesopotamian numbers
Numbers?
look like? I want to
Yeah.
see like
16.
how different is 57 to 45.
They must have a different way to call it. Like,
Yeah, right.
not 67 because there's space of 6 and 7.
You like it?
Let's see. Oh my God, this is happening.
It's like
I
little
know.
person shooting arrows.
No, it is just look at that. It's just literally numbers. It is actual literally numbers, okay?
Okay.
Yep. But oh yeah, it stops at 60. Okay.
Okay.
But
Well,
what's 60?
60, I don't believe it had a use for, you see, again, let's go back to this practical. Things that are more than 60, they didn't have practical use. Who would have, except the king, who would have more than 60 sheep or cows, right? For a long time, numbers were very practical. Now, let's move forward a little, okay? Now, people start doing math because then the king had more than 60 sheep or cows. King had soldiers, they had to pay them and so on. They start doing higher level math. And that was the reason we had to have numbers that we can deal with easier, better, more concise. And it's not by chance that these developed independently in many cultures that, especially in India, then all of a sudden the base of 10 became a big deal. Because with the base of 10, you have 10 fingers, okay, 10 fingers. You can go up to 10, and then you can just use, actually, as a matter of fact, the story is, I'm not sure if it's true or not, that they would use 10 and then they would use their toes and then go up to 100. And then there were other ways to then go even higher, but it became very practical way, specifically after they had the concept of zero. And the concept of zero was introduced again in India about, I would say, probably 2,000 years ago, more than 2,000 years ago, but it did not come to Europe until, when do you think the concept of zero, or no, number one, when did the Arabic numerals, we call them Arabic numerals for a reason that I'm going to explain to you, but the concept is actually Indian. When do you think that concept came to Europe?
1400s
Yeah, very good. Because
during spice trade.
because before that we used to use Roman numerals, right?
Yeah.
Okay. Do you want to try to calculate with Roman numerals?
They're kind of difficult to write.
It's a difficult to write, difficult to understand. It's a mess. Trying to calculate, even trying to do the multiplication, or it becomes a really messy thing, okay? Now, Arabic numerals or the Indian concept of the numerals are easier because multiplication and the division, it becomes a lot easier. Now, do you know what was even worse than Roman numerals or Chinese numerals or Mesopotamian numerals?
There can be something worse.
Oh, yes, yes. The Arabic numerals, because the original Arabic numerals, not the one that they took from India, and that's why they took it from India. They went and captured, they made them all Muslim, they did a jihad, and then they look, they have a numerals, it's so much better. I don't want to do that anymore. I want to use that. So, and then how they took it and brought it to Europe. It wasn't originally Arab, but we come back to that. Now, they used to use actually words, like actual words for the numbers. Okay, like each letter they could write, each letter had a number, and literally the position of the number, and they have about 30, I believe 32 or 30 kind of letters. Each letter has a number, and the original Arabic numerals are actually those letters. And I'm not sure if you guys have heard that some people think that there are some codes is embedded in the Bible, that they change the letter in the Bible to a number, and then based on those numbers, they think there's a hidden message there.
I've
Have
heard
you
of
heard of that?
Yeah, I thought it was just crazy talk.
We had
No,
enough
it is.
conspiracy theory recently.
Yeah, but it is not nothing into that, but that originally comes from that Arabic or Semitic language. Each letter was associated with a number, and I'm going to show you some of that here. And those numbers, that's what they use for calculation. It didn't work, but let me show you that what it looks like. Okay.
I mean, I heard of converting numbers to letters, but not from characters to numbers.
I saw that was just
Are you able to see it?
encryption.
Yes, we can see your screen.
Okay, well, do you see that? Like, are you surprised that the first letter in Arabic alphabet?
We're not seeing the Arabic alphabet.
I think you share the wrong screen.
Maybe you share a different screen.
Or maybe let me. Oh yeah, I did here. So, first letter in the Arabic alphabet is actually Aleph. It's not. It doesn't look like with something on top, something different on top. Okay, and actually, let me look for that here. I'm going to show it to you.
Now, most of it just show the simplified Arabic number.
Oh, here, this is Arabic. Do you see the Aleph, first letter of the alphabet in Arabic, look exactly like that, and so on. So we come back to this, but never assigned actual letters, and that didn't work well. But then we took the concept of the Hindu numerals, but then this very, very genius mathematician, his name was Al-Khwarizmi. Have you heard of that?
No.
Ask me.
No?
Does he live in
Okay.
Baghdad?
No. He lived in Khoraz. It's a city in Iran. Okay, so it is 8th or 9th century after the Christ, okay? AC. Arabs have conquered most of the Middle East and are about to conquer most of India and most of North Africa. They have this. They have brought the concept of the Arabic numeral, okay, and the official language everywhere is Arabic. Now, this Persian guy, he's Persian. He lives in Iran, today's Iran, in a city called Khoraz. So that's why they call him Al-Khwarizmi, meaning the guy from Khoraz, that city. Okay, like what city
What's
are
his
you?
name again?
Al-Khwarizmi. Al-Khwarizmi. Let me look first. I don't know in English how it's called. Al-Khwarizmi. Okay. Here, let me share the picture with you. This is the guy, Khwarizmi. Okay?
Ask me.
Lives somewhere in the north of, somewhere close to the north where it was used to be Iran. He's a mathematician, he's a genius. We can talk just 2 days just about him. So, this guy says, okay, how should we present data? How should we show how these numbers, how should we write them? I'm tired of using the Arabic way of writing actually with letters because that's confusing. I cannot calculate with that. We need new signs, we need new symbols for these numbers. So what does he do? He says, let's represent them with the number of the angles they have. So, zero wasn't there at first, but came very closely, very fast. Zero has no angles because it's a
It's a
circle.
circle.
Yeah, one has one angle, two at two angles, three at three angles, and so on and so forth.
Whoa.
This is the first time for me to know.
Yeah, same.
So,
Hmm.
and that is how we write Roman numbers, which is actually when they refer to Arabic numerals, they're referring about how we write it. Actually, the way we write numerals in English, they call it Arabic numerals, but surprise, surprise, it's not Arabic. The person who invented that was Al-Khwarizmi. It just happened all his books were written in Arabic because that was the scientific language, but he was Persian. So you're welcome. The Persian gave you the way you write the numbers. But why do Arab not write like that? Why do Arab like it like this? Different.
That's also simple enough, I think, if they learn it from their
Yeah.
childhood.
No, the Arabs write it different because they like the concept, but then they didn't want to use the writing way of that Persian guy because Persian, they conquered the Persian and so on. They wanted to use still their own letters, change the symbol a little, then write it. Let me show it to you. So I'm actually going to show you here. Just look for Arabic numbers characters. Okay. And if you look carefully here, you see that they like better use their actual what they used to use, but they just used it from 1 to 9 and then change that to make the symbol. Okay? So let's go back. There are lots of different ways of actually use the numbers. Base of 5, base of 16, base of 12, and base of 2 didn't really exist until recently. Base of 16 didn't exist until we start programming and we have computer chips that they had 16 because at first we had the transistor. Transistor is base of 2. Then we combined two transistors, then two transistors, you have 4 ways. But nobody really made a transistor with just computer with 2 transistors. That was ridiculous. But they did make computers that they had 16 transistors, so you had to address the memory 16 different ways. So hexadecimal. So base of 2 and base of 16 is the invention of the computer. But there were lots of other ways of dividing the numbers. But then about 6,000 years ago, we start writing it, and we use our writing to describe the numbers. Doesn't really work. We start to do things. Go to base of 10 and have extra symbols for the numbers. And then something magical happens. We invented 0.
Who
And then
invented zero?
well, Indian philosophers and mathematicians. Now, they accepted the Arabic numerals in Europe, but for a long time, they did not accept the 0. As a matter of fact, all the scholars, they were, oh my God, you're going to drive us crazy, 0, 0, 0. It took another 100 to 200 more years before they accepted the 0. Meanwhile, the Middle Eastern, Islamic, and the Persian scholar, they have been calculating with 0 and the numbers long time before. So you remember that guy, Al-Khwarizmi or Al-Khwarizmi? They took his name, his method of calculation, and he more or less he invented algebra. He came so close to invent analysis, so close. But life was too short then. Now, then his name, Al-Khwarizmi, was changed when it went to Latin. Do you know what came out of it? What was made out of his name, Al-Khwarizmi? The name algorithm.
Oh, algorithm, Al-Khwarizmi.
An algorithm, what you guys use, what is an algorithm, Misha?
Algorithm is like a way of computing. Like
It
a
is
set way of
computing, not a way, it's not a way of computing. Algorithm is computing, and computing is you do certain steps and you always end up with the same results.
Yep.
And that's what an algorithm is. You do it the same way, you follow the steps. And that is how he invented the algebra. Okay? You do these steps, and then you can trust the results will be always reliable. Whereas if you do it just crazy random way, your result might not be reliable. So the word algebra, it comes from him. Aljabr. Jabr means force, or meaning that the path you take forced you to go one route and one route only.
The force.
The force, Jabr.
What language is that?
Arabic, because he wrote all his books in Arabic, even though he was Persian. Okay? So the word algebra comes from him. The word algorithm comes from his name. Algorithm is his name. And now, all of a sudden, now we have these extra symbols, including 0 for numbers. We have a base of 10 that it's really easy to calculate. You just add another 0, you go higher, like logarithm, okay? You have heard the word logarithm, it all comes from this. You go, every time you go one number up in logarithm, you go logarithm of 10, you go 10 times higher, like 10, 100, 1,000, and so on and so forth. All of a sudden, you can calculate with bigger numbers reliably. And then we have math. Okay?
Then they go to
and without these concepts, we could never do higher math. And without higher math, we couldn't do anything. Absolutely zero. We could do nothing. Some people say math is not invented. Some people say math is discovered.
Yeah, I've heard of that.
Okay, and the universe, the language of the universe is math. If there are some aliens, the way we could communicate with them is math. And now I'm going to give you something. If there is an alien, all we need to communicate with them is math. And want something else. What do we know now? They don't know what, they don't know how we look like. They send a signal to us, and we need math and something else. What do we need to communicate with an alien force? You don't know how they look like, we don't know how the planet look like, because they can just send us signal. They can send us beep, 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 beep. Signal, not sound. It could be anything, it could be a radio, but we need that, and we need something else.
Physics?
Well, yeah, physics is universal. At least that's what we are assuming, right?
Yeah.
This is something that's engraved on the gold that is sent to
Voyager 2?
Yes, they tried that.
Voyager 1?
That. Yeah, they tried that. They put a symbol of hydrogen, and then based on that, they followed it and so on. But you need two things, math and spin.
And what? Spin.
Spin. Turning this way or that way. Literally right or left. Spin is the same thing, right or left. So how do you communicate? This is an extra. This is not the history of numbers, but this is extra. Tell me, how would you tell if I'm an alien? I don't know how you look like. I don't know how your planet look like. How do you tell me how to differentiate between right and left. And it's extremely important. Without that, you cannot communicate. You say, I will see you in that galaxy. If you don't know right and left, or left spin and right spin, I go to one way, you go other way. We never see each other.
Positive and negative.
How do you tell them what positive and negative is?
Use a
So
Simpson.
an electron, you call it positive, they might call it negative, or and so on and so forth. And
So it's
and
something
even
that
one
won't change.
electron has you have two electron pairs. One has left spin, one has right spin. So how do you tell the alien which electron do you want?
Left or right?
This is the deep thing. This is not trivial. Right and left, how clockwise, anti-clockwise. How do you make an alien understand which one is which one?
You draw an arrow, I guess.
But
You draw an arrow.
no, you can communicate only with signals. How are you going to draw an arrow? You need that language to make them understand how to draw an arrow. If you're just communicating with signals, numbers, you needed the right and left to make understand what those signal means. You want to guess? Throw a few options out there. You cannot guess that because this is a very, very deep physics.
No.
Odd number, even number.
That's no, it's very much more basic than that.
Much more
Okay,
basic
because,
than that.
well, odd number, even number, that is when you can divide by 2 or not.
Oh
But
yeah.
first you have to make them understand what the numbers are and what they mean and so on. That is right and left, clockwise, anti-clockwise. Okay, I'm not going to torture you. I'm going to tell you.
Yep.
Now, what you do, you draw a hydrogen atom, one nucleus, one electron goes around it. And then you continue it until like two proton, 2 electron. That's helium. You continue it until you are on cobalt. And then you draw the number of the cobalt, the number of the particle in the cobalt, and the number of the electron. The number of the electron tells you it's a cobalt, and the number of the thing inside tells you which radioactive element of the cobalt we are talking about. And then you let it decay, and you will see that 93% of the decay elements are turning the left, only 7% are turning right. And that's how you describe universally right and left. You could not have guessed that because nobody could know that. Nobody philosophically could explain to you without looking at a human or a clock, describe clock, counterclock, right, left, and so on. But that is the universal language that you describe to them, the cobalt 73, and then I think it's cobalt 73, and then you tell them, watch it decay and see in which direction the electrons are going. Are they going this way or that way? Because 97% of them going the direction that we call left. Okay? Isn't that crazy?
Yes, I'm
Does
thinking.
cobalt decay at all? It has what, 27 protons? 27 protons, right? In its atom. Yeah.
But certain cobalt, when it decays, that is how usually they decay.
I'm just thinking how aliens gonna understand that
Well,
without
no,
such
it's actually, no, it's easier than you think. You remember on the Voyager plaque, there
Yep.
is a one proton and 1 electron. That's hydrogen, right?
Hydrogen. Yeah.
Yep.
And then you continue that until you get to something that has 70 or whatever number of the electrons on the cobalt is. You can look it up.
27.
27.
Yeah,
And
I'm
then,
pretty sure.
and then when it's 27 in the nucleus, you put like 72 dots or something, meaning that this is a certain kind of cobalt, and you just take it and let it it consistently produced material that 93% turn left, what we call left. Okay? So now it took us a long time for us to be able to universally describe. Without nuclear physics, we couldn't describe right and left, except using human picture things. And now we can. Now we can describe to aliens what right and left is, and as well what the numbers are. Okay, I think at the end of the day, if you are going to communicate with the alien species, it doesn't matter what base we are going to communicate with them.
Yeah.
Because we are at the point that we understand math is its own thing. It is math is, we don't truly, I do believe in that. We don't invent the math, we just discover it, and we give it a, like, it is an animal, like an animal in Amazon. We give it a name, but that animal existed there even before we discovered that animal exists. And that animal doesn't really, cares. There are concepts in math that are so universal that the truth of the existence, the base of the existence is a mathematical thing. It must be. And that is what actually the theoretical physics does, to bring us to the basic of the math. But I can just tell you, even though that all of that exists, we could not understand it without these numerals that we can calculate. And that's what the history of the numbers are, truly helping us to understand the base of, like if we didn't have letters, we couldn't give that animal in the jungle a name. If we didn't have language and letters and sounds, that language, that's what this history of the thing is. It's enable us to discover math and give it actual name. Okay.
Yeah.
Okay. This is very exciting, actually.
Yeah, it's very deep also. Yeah.
Deep,
It's very
man.
deep, actually. Yeah. Now, but coming to that, because Arabs, they had, every letter had a number. When this concept came to Europe, they did the same thing then to Bible. They said every letter has a number, and those numbers are codes for something else. Not understanding that the Bible we use today, it's 5 translations. It's English from Latin, from Greek, from Hebrew, from Aramaic, and so on. So even if they had the numbers, they don't have to comply with the numbering for Roman numbers and Roman alphabet anymore. Okay, so, but you see, some things we are just, we just love to attach mystery to things, or
because it's just the Bible is too long that there
And
could
there's-
be coincidence.
There's so many
choice.
additions from
It's
so
like-
many languages, right?
A monkey can write a book if you give it
Enough
enough
time.
time.
Oh, yeah, that is a concept. Oh, now that you said that, we have to talk about it.
Oh, that is deep, man.
That is very deep. Okay. Now, if you had infinite amount of time, an infinite amount of monkeys typing randomly, that is the concept you're referring to. Infinite amount of monkeys typing just in typewriter. Eventually, one of them would be writing
Shakespeare.
every Shakespeare, exactly. Okay, now let's talk about another random things. Pi, right? Pi is infinite and pi is random, correct?
Yeah.
So what if I told you, Jimmy, your entire life story is in pi? Infinite amount of time. So infinite amount of time, your entire life story, if you would just take every 3 numbers in pi and assign it to a letter, like A, B, C, D, and so on.
Yep.
And then just start changing every 3 to a letter, and you have just gamut of letters, right? Eventually you will find, you can calculate actually.
You can
Eventually, how
find a
often?
number.
Eventually, you will find a letter. Eventually, those letters are going to make sense. Eventually, those words are going to make a full sentence. Eventually, those full sentences are going to compile to a story.
And it could be my
And
story.
it would be your entire life story. Now, how many times will you find it in the number pi? Your story in number pi. How many times will you find it?
Once, because it won't repeat.
No, no.
Infinite amount of
Infinite.
times.
Infinite amount of time. You will find,
Okay.
if you go long enough in pi, you will find your life story, our conversation that we just had, or we will have in 5 minutes, will be infinite amount of time in the letter pi, in the
Oh yeah,
number
it
pi.
can come up again and again. Just
Yes,
open
because
it.
it's infinite and it's random.
Yep.
Okay, so try to wrap your head around that everybody's life story is infinite amount of time in the pi. Okay,
Yeah.
okay, that is a good finish for our podcast. But these concepts are truly what makes our life possible. Okay, so these are not just like random things. Without the pi, none of our technology would exist without the number pi. And we couldn't do any of those math that make our current modern life possible without these numerals. And it's interesting to know where they come from. It gives you a much deeper understanding about where they come from. But the most important thing that I really was proud of when I found out about that is that what we call Arabic numerals, we are not just talking about the concept, we are actually talking about how we actually write the numbers in English. And it's not really Arabic, it's Persian. Okay?
Yeah. Thank
Okay.
you. Thank you for people too.
Wow, deep.
Okay, well, let's wrap it up. Amanda is not with us. She would have learned a few things. But I'm Dr. Abbasi for Essence.
And this is Misha.
I'm Jimmy.
Thank you for joining us for this podcast. Bye-bye.